Some final things here. We all good with the minor details? Where, when, the time, pen, pencil, bubble sheets, where everything goes.
The answers to 8 to 10 on the booklet or on Aspen.
What?
For unit sure. It goes to 7.
Okay, so they're not on there. Okay, I'll post them sooner or later then. Okay, I can get them on there pretty quick. Yep. Correct. Now, I don't know if I talked to you about this yesterday, but let's say you are given a coordinate proof. The graph can be in pencil, but all the surrounding work, midpoint, distance, slope, has to be in pen. All right? Just because you see a graph doesn't mean the whole thing is in pencil. The graph only is in pencil. You may also hear other teachers telling their students, pen, pencil doesn't matter. It matters to me. All right? We are all pen. All right, except for the graphs and constructions. All right, so don't ask, well, they're doing this. We are all pen. All right, we are all pen. On Monday, I think it was, I gave you guys maybe Tuesday, sorry, and Wednesday. I gave you formulas, properties, special vocab. Make sure you know those down cold coming in on Tuesday. Constructions. Actually, you know what I wanted to do with constructions, and that is let's list them out. We did that 7th period yesterday. All right, so I think I should probably give you guys the opportunity right now to let you know what constructions you're going to be responsible for, because there's some I don't want you to waste your time on. Open it up to you guys. Let's roll. Okay, medians. Let me back up before, because what construction leads you to a median? Perpendicular bisector. All right, perpendicular bisector. That leads you to a median. So let's keep digging deeper now. If that leads you to a median, that will also lead you to the what? The intersection of the medians, which we call the centroid. This construction will also lead to, where are medians drawn to? Where are medians drawn to? Midpoint. So it will, if I ask you to find the midpoint, that construction will do it. So that construction, as you can see, is pretty powerful. I got one more. Where do all 3 of these intersect at? Yeah, pretty powerful construction to know. And then what's built off it? All right, what else do you think could possibly be on there? Angle bisector. Which would lead you to the what? In center, yep. Another construction. Okay, altitude, let's pick that up. What would get you to an altitude? Perpendicular to a line through a point not on the line. So perpendicular to a line through a point not on the line. So can you draw a line perpendicular to this one but going through P using your compass? That, yes, that will lead you to how to do an altitude. That is the same construction you would perform if I asked for an altitude to be drawn. And yes, an altitude does lead to an orthocenter, but I told you guys already, don't worry about it, so I'm not writing it down. Others? Nope, don't worry about constructing triangles. That's a pretty big chunk to remember, so don't worry about it. There's probably one more I'd worry about. Copy a segment on an honors midterm? No thanks. Copy an angle though, maybe. And I'll leave it right there. I told you how many constructions are on there? 2, yep, a major one on part 4 and a secondary one somewhere else in the test. Now, when I say 2, that means 2 you do by hand using your compass and straight edge. There might be something in the multiple choice where I do a construction and say, what did I do? Okay, I may ask a question based off the construction I did. But 2 you have to do by hand using your compass and straight edge. All right, all good on your constructions that are possible. Calculator, get them out if you don't have them out already. Here we go. Okay, I give the instructions. Go ahead, everybody. Please clear your calculator. Where are you guys going? Second plus. 7, reset. Go over to all, scroll over to the right to all memory, and reset it. And again, you either have RAM cleared or MEM cleared. Please keep that screen up until I hustle down the aisle looking at your calculator screen. All right. Please don't want to make me stop, please. You do not, nobody asked this yesterday, but you do not have to worry about being in a certain mode once you clear it. We're not there yet in that part of the year. You don't have to go back to your mode and change it into a certain one. The only mode you need to worry about is yourself, and that's being in beast mode. Got it? Okay, you don't have to worry about your calculator at all. Anything else on the calculator, Vincent? Yep. No, do not bring scrap paper. Ask if you need scrap paper. We'll give it to you. Okay? Do not bring any in, though. There will be the graph and the formula sheet attached to your packet, so you can use that for scrap. But if you need more, certainly ask. We'll get it to you. Okay? Same thing with graph paper. If you need an extra sheet of graph paper, let us know. Anything else there? And let's see what else. Finally, I had watch your time. It's 2 hours. You don't get any more than 2 hours. Okay, the test is not designed to be over 2 hours. All right, so please watch your time, especially if you're struggling with 2 or 3 problems. Don't waste 15, 20 minutes on it. Okay, just come back at the end. All right, please. I'll be yelling out an hour, half hour, 15 minutes. All right, please watch your time because you only get 2 hours. Anything else? All right, and that quote up there is really not designed for motivation. I truly believe that. There's no halfway here. All right, halfway will get you probably in the 70s. All in here or get what you get based on all your knowledge. Anything last minute you want to ask about the tests? I think I've covered everything pretty clearly here the last couple days. Questions, topics time. Here you go. Anything we want to cover that you've come across in the last 24 hours? Did you get my polygons? Okay. Anything, topics, questions wise? Go ahead, Meg. What's up? Page 53, everybody. Let's see what we're working with. Okay, looks like we got an indirect proof to try out here first. Yes? Okay. Shoot. All right, let's roll. What's my assumption? I know this is indirect, so what's my assumption? XB is perpendicular to AC. Always go to your proof statement, do the opposite. That's my assumption. All right, now I understand why Meg maybe picked this one. It's not very clear which one, out of the two givens, which one I'm going to try to contradict, because I don't see the word not there. Because usually that's the one I pick off right away. All right, so out of these two givens, I'm actually going to contradict ABC is scalene. How can you contradict that it's scalene? Show it's isosceles instead. Okay, that contradicts that it's scalene. So our goal right now is to show ABC is isosceles. All right, so we were given that the two angles are congruent, ABX and CBX, and I can't stress this enough, use your assumption as a given. So those perpendicular lines form right angles. All right, so that's the first thing I can say here is that angle BXA and angle BXC are right angles. Perpendicular lines form right angles. And if I take a quick glance at this, am I going to use HL to prove the triangle's congruent? No, so I need to say that right angles are congruent. All right, so I have two pairs of angles. Where's the side? Reflexive side BX. Triangles are congruent. What method out of the five? Angle, side, angle. Again, I know we've been going back and forth, but make sure you got the congruent sign there. ABX congruent to CBX. Angle, side, angle. Why would that help me out knowing the triangles are congruent if I needed isosceles? Either the sides or the angles now are congruent. I'll just go sides. So we now know that AB and AC are congruent. BC, sorry. CP, CTC. That makes ABC isosceles. That's a problem because in the givens it said it was scalene. Why is it isosceles in a triangle? Two congruent sides imply an isosceles triangle. And now we have a contradiction. So XB is not perpendicular to AC. Assumption led to contradiction. You can write the perpendicular with the slash through. I'm good with that. If you don't want to write in words. Now that I think about this, I should have added number 6 to this, and that's discipline. What do you mean by that on Tuesday? If you solve for a variable, stop yourself and make sure you've answered the question. All right, stop yourself, make sure you've answered the question. Other topics or questions? Orion. Somebody has finally asked me for what I consider the toughest proof on here. Looks like you guys are going to get a whole day on Sunday inside, cooped up, huh? So nothing better than the stuff. Big party in here tomorrow, 12 to 3. Looking forward to that one. All right, you ready here, stud? What do I already know ABCD is? Parallelogram, got to make it into a rectangle. How does that get done? One right angle or diagonals congruent. That's probably out of the question here. Why is that? There are no diagonals. BM is not a diagonal. Diagonal attached is connected by two non-consecutive vertices. So the only way I'm going to do this here is if I can get a right angle somewhere. All right, everyone agree? All right, so I'll help you out here because this one is a little bit tougher. Can you first prove the triangle's congruent? Can you help me do that? It's a parallelogram. I got a midpoint. I got a lot of stuff here. Help me get the triangles congruent. Go. What's next? AM equals MD, definition of a midpoint. What else can I say to make the triangles congruent? BA is congruent to CD. Because in a parallelogram, opposite sides congruent. So now that is plenty of information to say triangle BAM congruent to triangle CDM. Side, side, side. Now here's where it gets a little crazy. Usually, why do we prove triangles congruent? To prove either a pair of angles or sides, right? By CP/CTC. What do you know about angle A and angle D right now? They're congruent. Okay, let's keep going with that thought. That A is congruent to D by CP/CTC. What type of figure is this right now, ABCD? It is a parallelogram. Anybody remember the property about consecutive angles of a parallelogram? Very, very, not used often, but they are supplementary. So not only are A and D congruent, but they're also supplementary. They got to be what type of angles? Right angles. Okay, it's just how do we write that? Well, first I got to say that angle A and angle D are supplementary. And how did we know they're supplementary? Parallelogram implies, watch your mouth. You just gonna wolf down like a whole frozen pie before you come? Yeah? All right, good. Pizza, another name for pie. Okay. You just roll into Gym A, just finishing off the crust, and you sit down and you're powered, ready to go. I know Paige is all in. All right. All right, now is, okay, how do I say A and D? I don't have like an official theorem here that says that angle A and angle D are right angles. Just explain to me in the reasons why. Two angles that are congruent and supplementary have to be right angles, something along that lines. I don't have an official theorem, and I think that's why kids struggle with this proof, because it's not something we've written down in the last 20 weeks. So two angles, congruent and supplementary, must be right angles. That's fine. And then now, what is ABCD now that I showed a right angle? It is a rectangle. So ABCD is a rectangle. This reason we have talked about. And that's what? Why is it a rectangle? Parallelogram with one right angle implies a rectangle. Yes, Colin.
Could you also have done it with the quadrilateral with 4 congruent angles?
4 right angles? Or just 4 congruent
4
angles?
congruent.
You could have. Would you do some addition there?
Yeah.
With CP, CTC, these two, and then these two are equal because they're across from congruent sides? I don't know. I'm trying to think how you got A, D, B, and C all congruent.
So I made.
So did you do opposite angles, couple substitutions?
Yeah.
And that's fine. Yes, you can do it that way. Yep. Yes. Yes, Vincent. Probably not. Nope. Probably not. Yes, Maggie.
I just proved I did angle A is equivalent to angle D, C, and then I went right to ABCD as a rectangle because 2 consecutive angles congruent. Or is I can't do that.
That's not true. 2 because I could show you a trapezoid with 2 consecutive angles. And I saw it. Ready? If you say, oh, a parallelogram, did you put that? A parallelogram with? Okay, if you write a parallelogram with that, yes.
Okay.
Because you can't write, here's the issue I have with 2 consecutive angles congruent just automatically means a rectangle. Remember our isosceles trapezoid? Base angles are equal and they're considered consecutive, but it's not a rectangle. But if you say parallelogram, then I'd be okay with that. Hi, Sinead. Yep. Could it be a rhombus?
No, because that's not. Because rhombus.
With 2 consecutive angles? Yeah, it's sides. Yeah, not angles. So I think that would be good if you add in the word parallelogram. Others? Anything else? Orion, yes.
Number 30 on
75. The isosceles right triangle? All right. You want it done, we'll do it. And again, I realize I've only given you 2 coordinate proofs. You can look back at your quadrilateral packet. We did a ton there. You want to throw me an email, I'll throw you back a bunch of coordinate proofs too. Not a big deal. All right, I'll make sure I have my laptop at home this weekend so I can just fire off anything you guys need. Okay, all right, and there's 2 parts to this proof. There's showing me it's a an isosceles triangle and also a right triangle. Okay, where do you want to start? You want to show it's a right triangle. Okay, then I got to show it has a right angle. All right, and what formula do I need to show it's got a right angle? Slopes, all right, and it's awesome to graph it because I can probably tell where that right angle is. So I'll just find the slope of NU and the slope of NF. Back me up here, guys. Up 1, 2, 3, 1, 2, 3, 4, 3/4 for NU. And NF, let's see, up 1, 2, 3, 4 over 1, 2, 3, so -4/3. All right, what did I just learn there? NU is perpendicular to NF because slopes are negative reciprocals. And that makes angle N a right angle. Because perpendicular lines form right angles. All right, I made it a right triangle. Now, how do I get it to be isosceles? What formula am I going to have to bust out here? Distance formula, and I think we could save ourselves some time. Do we see which two sides are probably going to be congruent? Same two sides we found the slope for, right? So NU, so I got to find the distance of NU, and I'm going to cheat here. I'm not going to cheat. I'm going to do this mathematically, but 1, 2, 3, 1, 2, 3, 4. People are amazed when they see me do this. All I'm doing is Pythagorean Theorem, by the way. All I did was make a right triangle out of this. I counted up 3 over 4. 3 squared plus 4 squared equals c squared. What do you do with c at the end? How do you get rid of the squared at the end? So that's what I'm doing. If you want to use it, sure, go ahead. It's called the Pythagorean Theorem. Okay. And I believe I know 3, 4, 3. That's a classic one. 3, 4, 5. And let's just make sure NF turns out to be the same thing. 1, 2, 3, 4. 1, 2, 3. Kids are like, how are you using slope to find distance? I'm not using slope. I'm using Pythagorean Theorem. And then sometimes I get, well, don't you have to find the third side just to show it's not equal to the other two? No, because if it comes out to be equilateral, an equilateral triangle is still considered isosceles. It still has two sides congruent. Okay, so no, you don't need to find the third side. All right, so what did I just learn there? For step 5, what did I just learn? NU is congruent to NF because distances are equal. And now I found out it was a isosceles right triangle. So good old triangle fun is an isosceles right triangle because, you guys help me out, why? Because it has one right angle, a right angle. It has a right angle and 2 congruent sides. That's fine.
Would you have to say that
The other 2 aren't right angles? Oh, okay.
that fun was a right triangle beforehand?
No, you don't need to. Could you? Yeah, you could have. All right, but you can plug it all into one at the end. Yes, Vincent. Anything I use, that's fine. You're cutting into dicey situation if you start using your own abbreviations. Bisector is not BIS. Okay. What's the other one that some of you guys start using? I can't think of it off the top of my head. That I saw. Oh, you guys want to abbreviate that, huh? But yes, anything I use up here is fair game. Colin.
Do we not have to show our work if we do rise over run?
Nope. I don't expect it. Orion. For self-respect, sure. Have some self-respect. Some of you guys can't even spell vertical yet correctly 20 weeks in. It's not CLE at the end. It's not barnacle. Vertical, CAL at the end. Yes, Vincent. I don't know. I don't know if you should expect a coordinate proof. I'm not going down that road. Good try, though. I like how you worded that. No, I gave 5 options, though, for those 3 proofs. So I'm not going that far and saying it's these 3. But if you want to guess which ones it's going to be, go ahead. But you're doing it again. Breathing. Too harsh? A couple days before the midterm? What did I do, Paige? What did I do? I don't care. What did I do? Is it a question or just a comment? That's a you problem, I guess, if it's the other 2. Anything else? Hi, Grace.
What are the 5 proofs?
The 5 that it could have possibly been, what do we say, parallel and perpendicular line? Quadrilateral proofs. Congruent triangle. What else did we say? Coordinate and indirect, yep. There are 3 proofs on there. I can tell you that the 3 will be somewhere in here. Okay. Now, don't just think like if I give you quad proof that these are off limits. In that quad proof, you can prove line zero. Okay, let's not just think that totally disregard this. All right, it could be a combination of a couple as well. All right. Anything else, Connor? Correct. Don't worry about kite properties. Kite is nowhere to be found on this midterm. All the other ones, though, worry about, but not the kite. Anything else? Okay, guys, you have the rest of the time. If I don't see you tomorrow or Tuesday before for the review sessions, good luck. I'll see you in Gym A at 1 o'clock on Tuesday. If you have not already, take a glimpse on Aspen so you know where you're sitting.